You should be writing this down. All right. We're going to find the degree of something, and then we're going to name something. So we're finding degrees here. We're going to start with something simple. What's the degree of that? What would I call it?
2.
Okay. It's got this second degree. What about this? What degree is that?
3.
Third degree. Okay. Let's do something different. What degree is that?
No degrees. 1. It's the first degree. Oh, yeah.
Okay, let's talk about what the exponents are for that. What's the exponents for x?
2. It's 2.
What's the exponent for x?
1.
What's the exponent for y?
1.
So it is a second degree.
So we're going to add them.
If they're two different things, yeah.
Degree of x is 1.
Degree is y of 1, so this is a second degree. Okay, let's try another one kind of like that. What's the degree here?
3.
Third degree. Okay, now we're going to talk about some names. We're going to name it, and we're going to tell us the degree. Okay? So, what is the name? And degree. Okay? And I'm just going to give you a couple different examples. We've got 17y x squared plus xy minus 5. Okay? First of all, look at this. Can you tell me what degree it is?
I know. 3rd degree. The 2nd degree.
It is a third degree.
Oh.
Right? Because this is an exponent of 1. This is an exponent of 2, so it is a third degree. Okay. How many different terms are there?
3.
Because we've got 1, 2, 3.
But what about the other x and y?
They're not separated by addition and subtraction. Terms, so that's a good thing to put down. Terms are separated by addition and subtraction.
So just do the ones.
So we would call, yeah, it has 3 terms, and so we call it a trinomial. Get it? For 3, trinomial. So if it's a third degree trinomial, we call it a cubic trinomial. If we could stop whispering, that would be great. No need to talk right now.
What's a trinomial?
Trinomial, like 3. You know, like a tricycle has 3 wheels. Trinomial has 3 terms.
So you just ignore the x and y minus 5.
Right, because that's a term, and that's a term.
Wait, sorry, so it's third degree. What about the x, y minus 5?
So we always go to where the biggest degree is.
Oh, okay.
Okay, so the term with the biggest degree, and add up all the exponents in that term.
And only use that.
Okay. So we've got, okay, so what degree is this new one?
The 2nd degree.
It's a second degree. Good. How many terms are there?
2.
2 terms. Okay. What's the leading coefficient?
The first one.
Leading means first, right? What does coefficient mean again, guys? The number in front. So the leading coefficient is 100. So that's leading coefficient.
Term does not include exponent, right?
Right. the number in front of the letters. So 3x, the leading coefficient would be 3. It would be 6x, right?
So why isn't this 100?
Because one has an x and one doesn't. So you can't put them together. If you have apples and oranges, you don't say, you say I have 3 apples and 2 oranges. You don't say I have 5 apple oranges. Right? Okay.
100x are the term.
Hmm?
100x are the term.
100x squared is one term,
Oh, x
3
squared is one term.
is another term. Okay, so we would call this a quadratic binomial, because there's 2, right? Binomial. Again, like a bicycle. 2 cycles. Bicycle. All right, let's do another one, and we're going to name all these things. So I've got negative 9x to the 4th plus 8x to the 3rd minus 7x plus 1. You're going to tell me number of degrees, number of terms, leading coefficient, and the name. Okay. What is the degree?
4.
4th. Good.
What?
Why? Remember, it's whatever the biggest exponent is in that term. So here's the term with the biggest exponent. Well, it only has one exponent. It's the 4, so it's 4th degree. This up here is just one term. That's why we add them together.
Oh. Okay.
That's a good question, Laura. People make that mistake all the time. Okay. How many terms are there?
4.
4. Good. What is the leading coefficient?
7.
Negative 9. The leading, so in the front, coefficient. All right.
There's more numbers.
Yes, but what is the leading one? The one in
Add
front.
them together.
No, because these don't go together. I can't. Do you say there are 10 desks and 4 chairs in the room, or do you say there are 14 desk chairs? No, they're separate. Okay. Now the name of this one, how many, okay, so if we have only one term, do you guys remember what it's called? Monomial. Good. Monomial.
Oh, it was something.
2 is how much? Binomial. 3 is anything bigger than 3 we call it just a polynomial. Okay? So this is called a 4th degree polynomial.
Wait for that, you're looking at what's number?
Anything bigger than 4 terms, we call it a 4th degree. Anything bigger than 4 terms, we call it a polynomial. 4 terms or bigger. Okay. All right, let's do some notes.
I thought this was.
Now there's notes where I actually gave you the questions and I printed them out for you so you don't have to write them all down. Aren't I just the best?
I like
Okay, we're gonna skip this first one and come back to it if we have time. But I'm looking at the time. I don't think we're. All right, we're looking at example 1. Why is a plus b squared considered a special case? And I'm going to show you why it's a special case. Because if you have 2 numbers where it's a plus sign in the middle and it's squared, you don't necessarily have to, there's like a formula to it. Now we can go ahead and do this again, right? Make the box, or or you can FOIL. But we're going to end up with a squared, a times b, b squared. So we're going to get a squared plus 2ab plus b squared. Mm-hmm. So we can follow this pattern right here for anything that is squared. So do you see the next one? How it's 5x minus 3
Wait.
squared?
What did we learn about? So like it's the degree is highest degrees in front.
The highest degree is in front, squared is in front.
Like
Why aren't these both in front?
yeah.
So that you can see that it's a perfect square. It's a really good question, Caleb. Mathematically, we don't ever do that, and I don't really have a good answer for you why not. Because when we multiply something together, we always leave it in that form. I'm going to tell you, usually, this is not a square. This ends up being a number.
Why does this make it a special case? Is that what we're doing for all of them?
So I'm going to show you a shortcut. That's what I'm going to do right now. 5x is my a. 3 is my b. I can skip this if I want to and say, okay, I know I get a squared. So what's 5x squared? 5 times 5 is?
25.
And then we get x squared. Plus, in this case, we get minus. Yes. Okay?
What is
Because there's a minus right here.
No, but they don't you
Hold on. What's 5x times 3?
15?
Okay. Do you see that I did right here? I did a squared. Right there. It's 25x squared.
Yeah.
Now I'm going to do 2 times a times b right here. I know this is, you can always do it this way.
Yeah.
5 times 3 is
15.
15 times 2 is
10. I mean, 34.
30. So we get 30x. Then this is b squared. What's 3 times 3?
9.
That's it. Now, if you hate this way, you can just make the box or FOIL. We'll get the same answer. 5x times 5x is 25x squared. What's 5x times negative 3?
Negative.
It'd be a positive 30, so.
No. I'll show you. 5x times negative 3 is negative 15x, right? Negative 3 times
Oh,
negative
never
3 is
mind, never mind.
positive
Yeah.
9. And then we go 25x squared, negative 15x, and negative 15x is negative 30x. And we have plus 9 at the end. Okay. All right. We're not doing this one. I hate it. Okay. Let's go to example 2. Alright, we're going to learn about these special cases. It's basically showing us a shortcut. Do you have to use the shortcut?
Yes. No.
We have a plus b times a minus b. So again, I like to make, you can FOIL it. You can do them first, outside, inside, last, or use the box method. A times a is a squared. A times negative b is negative ab. B times a is ab. And b times negative b is negative b squared. So we get a squared. What's negative ab plus ab?
0.
So it's gone. Negative b squared. Okay, so you ready to see how this trick works with numbers?
Sure.
This one I actually think is not too bad. All it means is you square this one, and you square this one. What's 5x times 5x? 25x squared. What's 7 times 7?
Wait, 7 times
Negative 49.
7 times 7. I correct.
No, it's whatever. So this was my A. This is my B. You put a minus sign in the middle.
Oh, so you put the minus in the middle? Why?
Because then positive times a negative will be a negative. Okay? Again, I don't like to remember all these rules. I just put it in the box method. Nobody's timing me to make sure I do some of these faster than others, right? 5x times 5x gives me 25x squared. 5x times negative 7 gives me negative 35x. 5x times 7 gives me positive 35x. 7 times negative 7 gives me negative 49. I get 25x squared minus 49 because 35 and 35 cancel each other out. We're not doing C. Okay. A graphic designer is developing images for icons. The square pixelated image is placed inside a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image? Let x represent the length and width of the image. Okay. So, the point is, it is x plus 4 squared. Okay. So we're going to end up with, and then we have to subtract. So we have the total area. And then we're going to have to subtract it from the area of the image. Equals 176 for the area of the border. Okay? I don't think this is very clear, but this to here is x. And this whole length to here is 4x. I don't think that's written very well. So we have the total area minus the area of the image. That would be length times width, right? X times x. Equals 176. X plus 4 squared, again, you can just use the box method if you want, but if you use your shortcut, it ends up being x squared plus 8x plus 16 minus x squared equals 176. So I used my shortcut. Did I have to? Now, I could have gone down and done x4 and found out that it was the same thing. Okay? All right. X squared minus x squared gives me 0, so I have 8x plus 16 equals 176. I'm going to subtract 16 from both sides. 8x gives me 160. Divide that by 8. X ends up giving me 20. Okay. The image will be 20 by 20. Okay. So the total area of the image will be 20 times 20, which is 400 square pixels. Okay. All right, let's look at the homework for tonight. Okay, so fine. The rules are going to be faster. Okay? So, all you're doing is multiplying two things together. That's the whole front and the back. I know there's a lot, but again, you can use your rules to make it go faster.
You write the rules in.
So, you wrote them down in your notes. Okay.
So Raylan
I
always done
did.
like degree and like not early. Like
No.
I was just nervous.
No, you're just multiplying two things together. So, the two things again, the different ones is if you have a plus b squared, it turns into a squared plus 2ab plus b squared. If you have a plus b times a minus b, you have a squared minus b squared. If you have a minus b squared, you have a squared minus 2ab minus b squared.
How do you remember?
I mean, I have it in front of me. I don't. I always do it. Oh, this is plus. It's a negative and a negative. It's a positive. There we go. So those are the three rules. They do make it shorter to do.
It just feels long. It's not fun.
Okay. Here's an example. If I have 2x plus 1 squared, 2x squared, 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times 2 is 4x. 1 times 1, 1. I mean, just make the box then. 2x and 1, 2x and 1, 4x squared, 2x, 2x, 1, 4x squared plus 4x plus 1. I don't think they're that different. Yes?
Do you want us to do it in the front and the back?
Mm-hmm. I do want you to do the whole front and the whole back. Yep. I'm going to write it on the board. Okay, here's tomorrow's in case we're not going to be here.
Good afternoon, Lincoln High School. This is Marlene Goff
And Drew Bond.
with your afternoon announcement. Attention juniors and seniors. Washtenaw Community College will be visiting during lunch hours next Monday, February 5th. Please sign up in the counseling office if you would like an appointment to see them.
Any student planning on taking an AP exam, please stop by the counseling office to pick up a form. All forms and money need to be turned into the counseling office by Thursday, March 15th.
Any student interested in helping with the elementary and middle school Girls on the Run program, see Ms. Hotchkiss in the main office.